Hey guys, Mr. McKinney here, just doing part 2 of the Unit 2 review video. In the first video, we went over the definition of derivatives and differentiability. Now we're going to get into the basic derivative formulas and then the product and quotient rule. So the main derivative rules that you're going to need to memorize are the constant, power, sum difference, and then the first two trigonometry rules. We're going to continue to add to these rules as we go throughout the year. The most important rule is the power rule. If you cannot do the power rule quickly and efficiently, you're going to struggle in the rest of calculus. So the power rule says as long as you can write it as a power, multiply the exponent by the coefficient in front, and then drop the exponent by 1. So the power rule is the main one. Derivative of a constant is 0, because if you think about it, a flat line always has 0 slope. You are allowed to just add or subtract derivatives. So if you have two functions added together, you can just add their derivatives together. The same is not true for product or quotient. You have to memorize those rules. But sum and difference, you can just add and subtract the derivatives. And then we spread out the trigonometry rules throughout the course of the year. So the first two are sine and cosine. Derivative of sine is cosine. Derivative of cosine is negative sine. So they always switch back and forth, but if you start with cosine, you have to change the sign from positive to negative. All right, let's do a couple of examples. So in theory, you could use the quotient rule here, but you should not. If you see a single term on the denominator, you should try to break up the fraction. So I haven't taken the derivative yet. I'm just breaking up the original fraction. 3x to the fourth over 2x squared minus 2x squared over 2x squared minus 1 over 2x squared. And then I need to simplify each one. So 3 halves, subtract the exponents, makes it x squared. 2x squared over 2x squared is just 1. And this last part could be written as 1/2 x to the negative 2. Now that they're each in the power rule form, this one's a constant, but the other two are in the power rule, now I can apply the power rule and find the derivative. Notice f of x, f of x, f of x. I have not taken the derivative yet. Now I'm ready to take the derivative. So 3 halves times 2 times x to the 2 minus 1 becomes 1. Constant goes away. And then here, negative 1/2 times negative 2. Make sure you drop the exponent. So negative 2 goes down to negative 3. And then at this point, I would just simplify my answer. Technically, this is fine, but you would probably see it on a multiple choice, and it would be written like this. 3x, this goes away. This becomes a plus. The 2's cancel out. 1 over x cubed, or x to the negative 3. So the derivative of this function would be 3x plus 1 over x cubed. All right, let's do another example. If you have roots in your original problem, change them so that they are exponents. So for example, the square root of x is really just x to the 1/2. The cube root of x is really x to the 1/3. So before I try to take the derivative, I need to simplify this. So 2/3. If I have x to the 1/2 over x to the 3rd, I need to subtract. So 1/2 minus 3, or 1/2 minus 6 halves would be negative 5 halves. So 2/3 x to the negative 5 halves plus 4, and I'm going to rewrite this as x to the 1/3. Now I can actually take the derivative because they're both in the power rule. So 2/3 times negative 5 halves times x. If I drop this by 1, I'm going to be negative 7 halves. And then 4 times 1/3. And if I drop this, it's going to be x to the negative 2/3. I can stop here, or I can simplify a little bit. In this case, 2's cancel, so I'd have negative 5/3 x to the negative 7 halves plus 4/3 x to the negative 2/3. You might see it back with radicals. So you might see something like negative 5 over 3 times the square root of x to the 7th. Negative exponent needs to go on the bottom. Plus 4 over 3. This would be the cube root of x squared. That squared can be inside the root, or it can be outside the root. these two things are equivalent. The cube root of x squared and the cube root of x squared are both x to the 2/3. Remember that the number on the bottom is the root and the number on the top is the power, because the roots of the trees are on the bottom and the people with all the power are on the top. All right, when you have to find the second, third, and beyond in terms of derivatives, just keep doing the same rules. So here's my original function. The first derivative would be 10x to the 4th minus 8x plus 5 plus cosine of x. The second derivative, so this is my first derivative, also just known as the derivative. This is my second derivative. It would be 40x cubed minus 8. That goes away. Cosine switches to negative sign. The third derivative, I put 3 dashes, would be 120x squared. Now this one goes away. Minus cosine. I don't change the sign when I start with sine. So that was my third derivative. Fourth derivative, you put 4 dashes, or sometimes you'll see it with Roman numerals, or even a little 4. So the fourth derivative in this case would be 240x plus sine of x. Notice that sine just cycles. Sine, cosine, negative cosine, back to sine, and it would cycle again every 4. Exponents dropping, once you get down to a constant, it goes away. So to find the second, third, fourth, you can keep going. I could do a fifth derivative. You don't have to stop at 4. Just keep doing the same things. Okay, those were the basic derivative rules. Now on to the product and quotient rules. The product rule, if you multiply two functions, you can't just multiply the derivatives. You have to use the product rule. Now this was Mr. Jansen's slide. I prefer to teach it as v times u prime plus u times v prime. I like to just switch the order because then the order matches the quotient rule in a second. Since we're adding, it doesn't matter what order you do them in. Just make sure you take one function times the derivative of the other, and then flip-flop them. So for example here, my u would be x squared plus 1. My v would be 3x cubed minus 9. So I would write these off to the side. U equals x squared plus 1. V equals 3x cubed minus 9. Find their derivatives before you plug anything in. So in this case, 2x plus 0. V prime would be 9x squared. Now that I have u prime, v, and v prime, now I'm going to use the product rule. Now again, the way I teach it is v times u prime plus u times v prime. That order is probably backwards from Mr. Jansen's, but I like to have the same order as the quotient rule. So in this case, v, 3x cubed minus 9 times u prime, 2x, plus u, x squared plus 1, times v prime, 9x squared. And I could stop here if it was a free response question. If it was multiple choice, I'd probably need to keep going. So I'd have 6x to the 4th minus 18x plus 9x to the 4th plus 9x squared, and then combine it. So my f prime of x would be 15x to the 4th plus 9x squared minus 18x. But on the free response portion of the AP exam, you can stop as soon as you've done the calculus. The rest of this is just arithmetic. This first step was calculus. All right, let's look at the quotient rule. So same idea. You have two functions, u and v. Now, this is why I switch the order for the product rule, because then it will match the order for the quotient rule. The way I always remember the quotient rule, and the way I teach it traditionally, is if you're going to use the quotient rule, start with the bottom function and immediately square it. So whatever function you have on the bottom, just square it and put it on the bottom, and then put that function at the top without changing it. So v squared on the bottom and v at the start of the top. Then I can fill everything else in, remembering that I always mix and match one function with the other one's derivative. So v squared v, then I know v has to be multiplied by u prime, and then I subtract it and I switch the order. So let's do a quick example. This is my u over v. So if u is x, u prime is just 1. If v is 1 plus x cubed, v prime is 3x squared. So again, the way I memorize it, I don't remember that high-low thing. I just remember that whatever's on the bottom, you start with that and you square it. So take v and do v squared on the bottom and put v at the start of the top. And now I just need to mix and match. So since I started with v, now I need u prime minus, and now I need u times v prime. Again, if this is an AP question, I could stop right here if it's free response. It would probably be multiple choice. Usually you do not want to multiply out the bottom. It's usually going to be something squared. So on the top here, 1 plus x cubed minus 3x cubed, which would be negative 2x cubed plus 1 over 1 plus x cubed squared. Now, if you did multiply the bottom out, that'd be fine. You just don't have to. All right. The last type of problem is one where you're not going to actually have equations. They're just going to give you values. So it's asking me for f prime of 3 and g prime of 3, basically just asking me to use the product rule and the quotient rule. So for f prime of 3, since f is u times v, I'm going to need to do the product rule. So f prime would be v times u prime plus u times v prime. So now I just need to plug in all of the negative 3's. So f prime of negative 3 would be v of negative 3 times u prime of negative 3 plus u of negative 3 times v prime of negative 3. Now I can just plug in the different values. V of negative 3 was negative 3. U prime was 8 plus u of negative 3 is 4. V prime is negative 2. Negative 24 plus negative 8 is negative 32. So you do need to memorize these rules because sometimes you'll have to use the rules. Later on in course, we'll learn how to manipulate this so you could really just use the product rule. But sometimes you're going to have to be able to do it with a table of values or something like this. So this was for F. Same idea for G. So G prime, I'd use the the quotient rule. So start with v squared on the bottom, v times u prime on top minus u times v prime. Now I want g prime of negative 3. So now I need to put in all the values. On the bottom it's going to be v of negative 3, that whole thing squared, v of negative 3 times u prime of negative 3 minus u of negative 3 times v prime of negative 3. All right, so v of negative 3 was negative 3 times u prime is 8 minus, and then u of negative 3 was 4 times v prime was negative 2 over v of negative 3 is negative 3 squared. So g prime of negative 3 on the bottom I get 9, negative 24, this time the two negatives are going to become plus 8. Here it was a plus, so it became negative 8. Here it was a minus, so it became positive 8. So my answer should be negative 16/9. So you do need to be able to use the product and quotient rule, even though later on in the course you're going to learn some tricks to get around it. All right, the last thing in this unit was tangent, normal, and secant lines, and I'm going to record a quick video in part 3 for that.